Life in the real world versus high school, man. Some say no comparison. I say false. Everything on this page comes to life in many instances of daily living. The angles and shapes in a dull textbook can be found everywhere. Whether you are perched on a mountain or walking the streets below, there's no magic involved. Math helps us to understand and make predictions about the real world. Using real world situations, we will be able to solve problems that seem to make absolutely no sense at all. Trust me, seeing is believing. So, what about the angles of elevation and depression? Key topics in trigonometry. But what do they mean outside of this textbook? Let's paint a picture that we can all relate to. First, imagine a schoolboy. Let's call him X. He is standing on the ground, which is a horizontal plane. X is in uniform, but his mind is not on school at all. He's calling to his friend, who has climbed up to the top of a nearby tree to pick off some mangoes. Let's call X's classmate Y. And just for the purpose of this example, let's just say that the top of a tree where Y is seated is a horizontal plane. Now when X looks straight ahead of him, in his horizontal line of sight, that is, without tilting his head up or down, all he can see is the trunk and the lower branches of the tree. But what about Y and the juicy mangoes? Well, if X tilts his head up at just the correct angle, he will in fact be able to see Y at the top of the tree. This imaginary line is his inclined line of sight. The angle formed where these two imaginary lines meet is called the angle of elevation. So, what about from Y's point of view? His horizontal line of vision will allow him to see blue skies, buildings, and other trees. Now, looking down, his declined line of sight will give him the perfect view of his friend X. So this angle created by Y's horizontal and declined line of sight is known as an angle of depression. We can measure these angles everywhere. A child as she looks up at her kite flying in the sky, or a man in a lighthouse peering down at a boat in a distance. It's easy to distinguish elevation from depression. Better yet, picture your favorite batsman standing in Sabina Park. Just 4 runs are needed to win the World Cup. Now, he could bat a straight 4 to the boundaries, or he could aim higher, a magnificent 6 into the crowd. Now, that's elevation. The angle that marks difference between joy and jubilation. On paper, a cheap protractor is enough to calculate elevation and depression. But out in the world, many sophisticated tools are based on simple concepts.
Come on in, O'Neill. This is Caribbean Aviation Training Center's flight simulator. You may have a seat.
Okay. So, Captain, what are some of the instruments used as far as the angles of elevation is concerned in flying?
Well, importantly, angle of elevation allows us to take off and fly at a certain gradient of departure in order to clear obstacles. So it's very important. Some of the most important instruments we use today are designed based on the Global Positioning System, which is an electronic navigational system that uses satellite technology to describe the angle at which we need to climb in order to clear obstacles. If you look right here, it would be depicted sort of in this form, and you'd have a screen that describes the altitude in which the aircraft is traveling at, the rate at which it's climbing at, and the time at which it will take to get to a certain point. So it's a rather important instrument that will give you the information you need that you can fly safely and accurately.
And How is the angle of elevation important as far as flying is concerned?
Well, it's a very important question, because in order to determine at what point we need to begin a descent in order to arrive at the airport at the right altitude and speed, an instrument called an instrument landing system is sometimes used. On the airplane we have, it's somewhat depicted like this. It has a round circular face with a bar that goes across that guides the pilot as to the correct pitch attitude necessary in order to gain the descent angle he wants.
So, what are some of the other instruments that are used?
Well, on this panel, what we're seeing here is another version of the same instrument. In actual fact, this one is called a flight director system. And as you can see, it actually depicts the angle of ascent to the top where it's blue, and to the bottom you actually see the angle of descent, which goes down here. And what that does, it allows the pilot to preset the exact angle at which he wants to climb or descend. So it's a very good instrument and makes the workload a lot less during flying.
Okay, so it may not be your dream to find yourself in command of the cockpit of an A300 Airbus, or even a two-seater plane for that matter. But it is important to get some idea of how elevation and depression can be used to calculate unknown factors. To help you, let's do a basic review. Sine, cosine, and tangent are three ratios that show us the angle relationship between any two sides of a right angled triangle. Choose any angle other than a right angle. Call it B. We know the longest side of a triangle is the hypotenuse. It is always the opposite side to the right angle. The sine of angle B is the ratio of the opposite side to the hypotenuse. The cosine of angle B is the ratio of the adjacent side to the hypotenuse. And finally, the tangent is the ratio of the opposite side to the adjacent side. Wherever you find yourself, up in the air or in the middle of a forest, sine, cosine, and tangent ratios and the angles of elevation and depression can prove to be very useful in other calculations. In the following examples, we will focus on using the tangent ratios and the angle of elevation to calculate height and distance. Have you ever wanted to calculate the height of a tall tree? Some people do this daily. It's easier than you think. As you can see, it's very misty and cold. We're here at the Blue Mountains and John Crow Mountains National Park with Roger Thompson, Ranger. Right. Is it important to calculate the height of trees?
Yes, it is. For a tree like this, it's very important to have a measuring tape.
Right.
This is called the DBH, diameter at breast height, and this is how it is used. Alright, this is 35 inches, as you can see. But to measure the height, it would be very difficult. So a clinometer would be useful.
A clinometer is also known as an inclinometer. It is an instrument used for measuring the angles of slope or tilt, elevation or inclination of an object with respect to gravity. A clinometer is also known as a tilt meter, tilt indicator, slope meter, slope gauge, gradient meter, gradiometer, level gauge, level meter, pitch and roll indicator. Why is it important to calculate the height of trees?
So therefore you can know whether the tree is mature or not.
Okay. What is the optimum height for a tree for lumber?
This is anywhere between 25 to 30 feet.
Now before you run off to Amazon.com to buy a clinometer, let's look at the processes involved with calculating height. Like this. I'm on top of the world. Let us call the forest ranger R, standing near to a pine tree, and call the base of the tree B. How do we measure the tree's height? For all purposes, let us assume that the tree is perfectly straight and the ground is perfectly level. Imagine a right-angled triangle formed by the tree from top to bottom, that is TB, and the line between the ranger and the base of the tree BR, and finally the line connecting the point at which the ranger stands to the top of the tree RT. This is the right angle. The ranger knows he's standing 25 meters from the tree, so RB is 25. Using our protractor, we can determine the angle of elevation BRT, which is 38.5 degrees. Considering the right angled triangle TBR, the tangent of 38.5 degrees is equal to the height of the tree TB divided by the distance from the base to the ranger BR, or in other words, TB divided by 25 meters. So, TB is equal to 25 meters times the tangent of 38.5 degrees. Okay, so our calculators tell us that the tangent of 38.5 degrees is always 0.795, correct to 3 decimal places. So, TB is equal to 25 meters times 0.795, which gives us 19.875 meters. So the tree is approximately 20 meters high, rounded off to the nearest meter. Okay, so knowing only the distance between the ranger and the tree and the angle of elevation, we have been able to accurately calculate the height of the tree without leaving the ground. Let's make the problem a little more involved. The line of sight of the ranger to the tree is RP. Together, his horizontal and inclined line of sight, as well as the trunk of the tree, create a right angle triangle. Using the ranger's distance from the tree and the angle of elevation to the top of the tree, we can calculate the distance from T to the imaginary point that intersects with the ranger's horizontal line of sight, that is P. But what about the rest of the tree? If we add this distance, TP, to the height of the ranger, we will get the total height of the tree. Now, suppose we already know the height of the tree and the angle of elevation. How can we find the distance TR? Well, in this case, TR corresponds to the hypotenuse. For this problem, we will assume that the height of the tree TB is 40 meters and the angle of elevation BRT is 20 degrees. The sine of R in the angle BRT is equal to the opposite side divided by the hypotenuse. Our calculators again tell us that the sine of a 20-degree angle is always 0.342, rounded off to 3 decimal places. So, sine 20 degrees is equal to 40 meters divided by TR, the hypotenuse, or 0.342 is equal to 40 meters divided by TR. Therefore, TR is equal to 40 divided by 0.342. The length of TR is approximately 117 meters. And so, as you can see, the angles of elevation and depression have real meaning in the real world. Professionals in many fields such as aeronautics, marine, surveying, architecture, engineering have to use the angles of elevation and depression. A quick recap just to make sure that they're clear on this. The angle of elevation is the angle measured upward from the horizontal line of sight of an observer to an object. The angle of depression, instead, the angle measured downward from the horizontal axis to an object below. More on the angles of depression in our next program. Already you can see how using sine, cosine, and tangent ratios, we can easily determine distances between objects and the angles of elevation between them. Okay, So today we concentrated mainly on tangent and sine ratios. Now cosine is just as important. And now you may realize and agree with me that the angles of elevation and depression, sine, cosine, tangent are real life solutions to real